Hello, this is Felix from GMWolf, and welcome back to building a car game in GameMaker. Today we'll be looking at how we can improve the acceleration of our car in a more realistic manner. So before we start going into GameMaker, I think it's really important to understand how a car actually works. So basically speaking, you have your engine, which will deliver a certain torque, and then that will go into your gearbox, which will change the torque depending on what gear you're on, and finally it will go to your differential. Now your gearbox will have for the first gear maybe a multiplier of something like 2.6. I'm not exactly sure what the actual values are, but we'll be using values similar to these, maybe 2.0 for the second gear. The third gear might go down to 1.5, and then the fourth gear might be at maybe exactly 1, and the fifth gear is somewhere around 0.6. And your differential, which is the last part over here, is just a flat multiplier, which is somewhere around 0.6 as well for our purposes. Actually, this will change completely depending on our game. If the car is too slow and we want to speed it up, we might crank this up or crank it down. It really depends on how the car behaves. Now, what's actually very interesting to note is that your engine won't give out a constant torque. It's completely dependent on how many RPMs it's doing. So if we make a small graph over here, where the bottom is RPM on the x-axis, and the y-axis is your torque, you'll get something similar to this. You'll get sort of this kind of curve. And that's quite important because it means that where you're getting the most torque out of your engine is right over here. Now, what you should note about a car engine is that it cannot go over, or for most cars, will stop revving after 6,000 RPM. So that is our limit. And in a car, well, in a racing car at least, what you want to have is the best acceleration. That's really important. But you still want some top speed. And if you're in first gear, you have a multiplier of 2.6, but that means that not only is your torque higher by 2.6, but your RPM will also be higher by 2.6. And the problem with that is that yes, you are getting your top what do you call it? Your torque is at its max, but you won't really go any further, and so you then shift to your second gear, and so your torque is a bit lower, but at least your RPM can still go up, meaning your speed is higher even though your acceleration is slightly lower, and that's when you switch to third gear, etc. So this is what we're going to be implementing today. So I think that's enough explaining for the moment about RPMs and the different parts of the engine that we're going to simulate. So what we're going to do is open up GameMaker right here, and this is our old project. So we're going to be working on the last project we had, obviously, and we're going to open up our obj_car and start editing. Now, the first thing we want to do is setting up a few variables. So let's go into the create event. Actually, we're going to add a new code block because it'll be a lot clearer. And what we're going to first do is write down our gear multipliers. So we're going to create an array. And if you're unfamiliar with arrays, I do have a tutorial on it, and there'll probably be a link somewhere over here in this box so that you can click on it and find the video. Now, this is going to be an array, and it's going to be a one-dimensional array. So gear 1, we're going to have a multiplier of 2. Gear 2 is going to be 1.6. And by the way, I am making these numbers up and they might have to be changed, but I think these will work quite well. Actually, if I look back at the paint, we did start with 2.6. I'm actually going to do that instead. it doesn't exactly matter because in the end our differential is going to do most of the, these are just ratios between the different gears, and so in the end we can just have a global multiplier that can change all of our values. So as long as the ratio between the different gears is about right, we should be good. So this is going to be 1.5, then we're going to have gear number 4, which we're going to be setting to 1, and gear number 5 is going to be equal to 0.6. Now we need to say what gear we're in, so we're going to go current underscore gear is equal to 1. We're going to set up our differential, so we're going to call this differential. I'm not quite sure how you spell it, but I think that's right. 0.6. And that's about it for the variables. Now, remember how our engine will actually deliver different torques at different at different RPMs. So the way we're going to do this is create a curve, and the best way to do this within GameMaker is simply to create a new path. So create a path, and I'm just going to drag this over here. So at 0 RPM we have 0 torque. At around 100 maybe RPM we want a torque of 400, so let's add this one in. So at 0, 0 we want to add 1. Then we're going to change this to 96 and the Y to 400. So this will actually be at 960 we get 400 torque, RPMs that is, because we don't want to make a really huge graph that we can't actually see. So we'll have to times it later on. So let's add this point in. Next, we want at 200 RPM, we want to have a torque of 440. Let's add that one in. Next, at 300 or 3000 RPM, we want to have a 460. Let's add that. At, let's see, 400, we want to have 480. So as you can see, the difference really isn't huge every time. At 500, we're going to have 470. And finally, well, not finally actually, at 600, we're going to have 390, so it's already coming down. And finally, at 700, we want to have this at 0. Now, the reason we have this last 700 at 0 is because although we're never going to actually reach it, it's just to get that nice little curve thing over here. So we have to change a few things. First of all, we don't want this to be closed, and we want it to be a smooth curve, and let's up the precision to maybe 5. I did not add the 0, 0 point, so what we're going to do is insert one over here by clicking on the first number and pressing insert here and changing it to 0, 0. Good. So this is what our curve is going to look like. So our engine will always be at at least 1000 RPM, so this point is just to get a nice little bendy curve bit. And as you can see, it's going to steadily go upwards. At the beginning, we're going to have a nice acceleration, and then over here it starts dipping already. So we'll probably want to have our gear change somewhere over here. But we will make the gear changes manual or automatic later on, so that the player can actually choose between the two. So let's name this path to RPM m underscore 2 underscore torque, and torque is spelled like so, because it's a curve that converts RPM to torque. So let's press OK over here. Now the next thing we need to do is actually calculate what RPM we're going at, and that is going to be slightly complicated. Well, not too much, but what we're going to do first of all is start a new variable called RPM, and we're going to start at 0. The next thing we need to add is, let me check over here. I forgot to do my homework. Whoops, that's not what we want. Yes, we want to have our, where is it? Our, I can't seem to find it anymore. Aha, our wheel radius. Wheel underscore radius. And we're going to set it to 0.32 because that's around the radius of a car wheel, 32 centimeters. And now we want to go inside the step event. So this event here is just to have direction on the car. So let's add a new one, which is going to be calculating the RPM. And the way we do it is, if I go and check over here, because I did this before, just so I didn't get things wrong, which isn't actually always that easy, believe me or not. There's quite a lot of things involved in making such a game, and it really isn't always that easy. Here we go, I found it. So our RPM will be equal to our velocity. Now, oh yes, I knew I forgot something. We want to actually get our forwards velocity for this because the RPM will depend only on, if you're skidding on to left and right, your wheels aren't turning any faster. They're just, it's just your forward velocity. So to calculate our forwards velocity, we need to go inside this previous one here. Copy, where is it? It's not in here, is it? Should be. Oh, it's an entire object, of course. Copy this bit over here, just the top bit, and we're going to edit it inside this new step event. So let's paste it over here. So we're gonna change this LVX to FVX and FVY over here. And we're going to take away our plus 90 after these two bits over here. And this FVX and FVY will be the forwards velocity of the car. So now we need to say that our RPM is equal to our forwards velocity. So, well, that would be the distance between these 2 points, between 0 and these 2 points. So the way we do that is F forwards velocity is equal to the square root of the square of FVX plus the square of FVY, and that is just simple Pythagoras. So the RPM is forward velocity times our pixel to oh wait, no, we added it in here, never mind. So times our divided by our wheel radius. Yes. And we need to times it by our gear ratio, so gear current underscore gear, and that is because, remember, if our gear is higher or lower, I should say, you have a higher ratio on your gear, and so your engine is turning faster compared to the wheels. So let's put these two in brackets just so it's a bit clearer. And we need to times that by our differential. So times our differential. Yeah. And finally, we need to times that by 60 divided by 2 times pi. And that is because we're converting, we're basically taking our radius, timing it by 60 divided by 2 times pi. That is to get our circumference. And then, that gives us our the number of RPM on the wheel with the wheel radius and the forward velocity, and by timing it by the gear and differential, we get our current RPM of the engine. Now, once we have all this, put in brackets, we don't ever want it to get lower than 1,000 because our car will constantly be keeping the engine at 1,000 RPM. So let's max, and over here put a comma and 1,000. And this will keep the RPM always at 1,000 or higher. Next, we want to, let's see, add a force depending on our drive. So what we have to do is first of all calculate our drive, but in order to know how much drive we have, we need to calculate our throttle. And for the moment, our throttle is just going to be whether you're pressing up or not. So let's go delete this event right here with the up arrow. You can delete it now. Yes. Let's come back into our step event script that we just created and actually calculate our throttle. So our throttle will be equal to keyboard underscore check vk underscore up. And later on we will have to change this a bit when we're going to be adding more complicated things. For example, when we're going to add the clutch, for changing the gear, etc. So now we have our drive. We also want to create a new script to convert our RPM to torque, and the script is this one over here. So let me point this over the side and show you how it works. So let's create a new script over here, call it RPM to torque, like so. And remember, we already created a path over here which shows us the relationship between the two. And the way we're going to actually get it is by return path underscore get y. So path get y will take in a path and the position between 0 and 1. So it will take a path between 0 and 1 and return the y value on that part. So we're going to take our argument 0, which is going to be our RPM, between 0 and it's going to be around 7,000 because that's where our RPM to torque goes to. So, and we're going to divide it then by 7,000 so that it's always between 0 and 1. And there is an error somewhere. Well, that's right. First we need to give it its index for the path, so it's RPM underscore to underscore torque, because that's what we named it before. And then only put our argument 0 divided by 7,000. This doesn't need to be in brackets, by the way, and we can close this over here. Good. So now that we have our RPM to torque, we can start calculating our drive. So remember, we don't want our car to accelerate if the RPM is greater than 6,000, because your car will actually stop throttling at that point in order to avoid the engine being broken. So we're going to go if RPM is greater or equal, smaller or equal to around 6,100. Sounds good. And we're going to have our drive is equal to RPM to torque. Is it not coming up? RPM to torque. And we're going to give in our RPM as a value. And we times that by throttle. Throttle. I didn't spell that right, did it? It only has one T. I'm really bad at spelling. Times our throttle. Times our gear ratio. So gear current underscore gear. Times our differential differential times 0.8 divided by wheel radius. The 0.8 is to compensate for a bit of slipping, etc. And we're going to be making that a bit better later on. And if it's not, if RPM is greater than 6,100, so else, we want our drive to be equal to 0 because we don't want our engine to break. Now we can start adding our force. So the way we're going to add our force isn't going to be too hard. We're not going to apply it on each tire like before because it doesn't exactly matter. So we're going to do physics underscore apply local force, remember, at our physics center of mass X, physics center of mass Y, and that is to avoid, the force to be off center. Our force is going to be the drive we just calculated, and our Y force is going to be 0. So that looks quite good for now. Let's press save and save over here. Now we need to go inside our room and edit a few things, make it a lot bigger, just add a 0 on each end over here. Let's take our view and make it follow our car object, enable the use of view and visible when room starts, and object following down there, just select obj car. And let's create a very simple background just so we have a kind of a reference to what's happening. I'm just going to paint it all dark green, take out this and kind of make little squiggly lines so it looks a bit like some sort of grass, I'm not quite sure. Just making it quickly so we can see what's going to be happening. So let's open our room and assign the background over here. Now I'm going to open our sprite for SPR car and I'm going to fill it so it's a bit more visible. And let's try this out. Now we didn't add the changing of gears yet, but we're going to come to this right after we test this just to see if we did everything correctly. So we can see what's going on. So here's our car. If I press forwards, it's already turning. So something's wrong and I'm not quite sure what it is. I honestly don't know. So we do have our forces. Oh no, that's right, that's right. This physics, this part over here is supposed to be 0, 0, because this depends on the position of your car. So it's relative to well, actually it's the X position of your car, and at the moment our center of mass is exactly equal to our X and Y position, so we're not going to bother with calculating this right now. So actually we're supposed to set it to 0, not physics, X, as I spent so much time doing. So now it should be fixed. So as you can see, I can press forwards and I'm going to start moving forwards, and I forgot to center the view correctly, but at least we can see what's going on. And as you can see, it's already going faster, which is nice. However, we didn't add the gears yet. So let's get working on that. First of all, we want to change a few values which we set earlier, and that would be our differential value. We have it set to 0.6 or something, which actually we're going to change right now to 4.2. Next, we want to add in an event, which is going to be our key press shift, which is going to be shifting our gear upwards once, and we're going to go if let's see, if current underscore gear is smaller than 5, they will go up to 6 actually in all gears, I can't remember. We went up to 5, so if it's smaller than 5, current underscore gear plus is equal to 1. And so that will add 1 to the gear we have, as long as it's more than 5, so it won't go any higher than 5. Now we'll do the same thing for event control. Where is it? and that will actually shift down a gear. So what we need to add is if current underscore gear is greater than 0, greater than 1 for that matter actually, because we don't want to be lower than 1, current underscore gear minus is equal to 1. Good. Now what we need to do is when you're actually changing your gear, you want your clutch to, you know, come off and then come back on for a little bit. So we're going to go inside our create event and this code right here, add a new variable clutch, and we're going to make that equal to 0. Now later on we're going to be, right now we're just going to make the clutch on and off, but actually equal to 1 by the way. But later on we're going to have it so that it slowly, gradually goes on and off like a real clutch, so that it's more realistic, but I don't think we're going to have time for that right now. So when we change the gear, we also want to check if our clutch is currently on. So if clutch is equal to 1, and clutch is equal to 1 over here, and we're going to make clutch equal to 0, and we're going to make alarm 0 be equal to, let's say it takes around half a second to change your gear, so we're going to set that to 15 because we're running at 30 FPS. We want to go inside our control events. Once again, check if we have our clutch on, and clutch is equal to 1, sorry. And we want to go clutch is equal to 0 and alarm 0 is equal to 15. Now let's go inside of alarm 0, and all we're going to do is set our clutch back to 1, so clutch is equal to 1. And finally, inside our step event, this one over here, we want to get our drive, and we want to times it by, actually no, not drive, our throttle, and times that by clutch. Awesome. So let's save all that. Before we change too many other things, we actually want to check something in there which I might have done something stupid about, because our path_get_y actually returns a value between 0 and 700 and 300 and some, sorry, our RPM is actually maximum 700 over here, so we're going to have a few problems. So we want to take our argument 0, sorry, take out this value here and times it by 10, so that it's between, I feel like I'm saying something stupid. Argument 0 and times that by 10. And we want to go inside our step events and add one last thing. This is going to be quite important to add right now, and that is going to be our friction. The way we're going to do that is, first of all, we need to define a new value, which is going to be, again, you know, it can be changed. It really depends on what's going on with your car. We're going to call it CD, and it's going to be equal to 0.5 times 0.3 times 2.2 times 1.29. And each of those values actually means something special. I can't actually remember which stands for which, but basically speaking, I think 0.5 is the shape of your car and the aerodynamic properties of it. 0.3 would be the surface area. 2.2 is, if I remember correctly, a factor which is to do with the air density, and 1.29 is to do with the air density, and 2.2 is a multiplier just to get something nice and usable. Now you could type this all into a calculator and get the value out of it. I'm not going to do that because I know these numbers work, and it's only run once, so it really works fine for me. I'm going to keep it like so. And then inside our step event, what we want to do if you can bring up the code we need, because I can't remember it off the top of my head. We want to add inside this event right here. I can't seem to get my code back, which is annoying. Yes, a lot of forces going on, and I don't. There's no way I can remember them all off by heart. We want to say that our x force will be equal to the sign of our physics linear. Whoops, that didn't work out. Physics linear velocity x times the square root the square, sorry, of physics underscore linear velocity x times our room pixel to ratio, which is 0.025. So we're going to times that by 0.025 times minus CD. And we're going to copy all of that, paste it right here, and changing this to y, this to y, and this to y. And this is basically an approximation of the friction forces you're going to get. The square bit is the most important bit over here. But since you're squaring, if it was a negative number, you'll lose the fact it was negative, so that's why you're timesing it by the sign of physics linear velocity x. And so finally you want to apply the force. So physics, apply force, physics underscore center of mass x, and this part is important, you do need it, not 0, 0. Physics underscore center of mass underscore y, x force, y force. So I think this is pretty much all we need. Just to make things a little easier, let's add in a drawer event and do drawer underscore set. But more importantly, go inside the drawer GUI event. And let's draw two things. The first being drawer underscore text. At 0, 0, we want to draw our RPM, so let's put this code in, plus our RPM, so string RPM, so that we can see what our RPM is currently. And then drawer underscore text, we're going to draw that 20 pixels lower, and we're going to draw our speed, so speed, and I think this is going to be in meters per second, maybe kilometers per second, I'm not quite sure. So you want to go, let's go back into a step event and copy some code. I just want to copy this bit over here. And this is going to be the square root of the square of this physics linear velocity x times 0.025 plus the square of, and again, this is just Pythagoras to calculate our overall speed. I'm sorry, you're supposed to have a comma over here. Just so that we can see our overall speed, and this will be in meters per second. So to change this into meters per kilometers per hour, you need to divide the whole thing by 1,000 to get it into meters. Sorry, not to get it to kilometers. And times the whole thing by 36,000. Let me check. I never remember the number. It's 60 squared. Yeah, 3006. So basically just times it by 3.6. So timesing meters per second by 3.6 will get it into kilometers an hour. So let's save that and see how it behaves. Now, the speeds will be very unrealistic. We'll have to change a lot of values for it to be right. So as you can see, if I can get this working, of course I can't get it working because it always does that. It never works. Now, I have to be honest, I'm not sure where it's not working. Is our clutch on? To be fair, if something goes right the first time you try your code, it's not normal. Let's take out this last bit and see if that was a culprit. Because sometimes if you haven't adjusted your values correctly, this can go a bit overboard. But apparently it wasn't. So our RPM is always shown as 0, even though we are maxing it to... Oh, I see what the problem might be. Actually, I don't. Our RPM is... I see what the problem is. So remember, check your spelling. I just wrote RMP instead of RPM over here, and that made the whole difference. Because GameMaker will actually create a new variable instead of telling you it is a new variable which doesn't exist yet. So now everything should be fixed unless there is an error. And again, there is. This here is supposed to be RPM, not RMP. Yes, when I tend to type too fast, and I always put letters in the wrong order. So now this should work fine. Theoretically. Of course it doesn't, because why would it work? So yes, you can now see how debugging happens. You have to read through your code and see what isn't going right. So I honestly don't know what is going on. Our drive seems to be using the right values. Let's go back to our RPM to torque, take out this times 10, see if this makes any difference, because I was kind of thinking about this times 10 and it seemed kind of weird at first, but yes, here we go, that works. And so as you can see, we're now doing 67 kilometers an hour. If I press shift to put my things up, I'm able to go faster, but my acceleration is lower. Now, we got off screen, but we can still read the numbers. I'm now at 6,000 RPM, so I can't go any faster at 87 kilometers an hour. If I press shift again, I can go up to 120. Shift again, and I can go up to 130. But you can see my acceleration is a lot lower. My acceleration is about 1 kilometer per second. So what we're going to do, just for this demonstration, is adjust our view. First we'll make the room a lot larger, which is probably not advisable actually. Let's make it this large. And take our view and taking our H border and our V border to 640 and 480. So yes, there's been a lot of debugging this, but I think we're done. We have a nice realistic acceleration model, as you can see. It's a little fast, but once we get some more texture, it'll be fine. As you can see now, when I turn when I'm at high speeds, I actually get some drifting going on. It's not quite visible here, and maybe on the video it will be even less visible. But hopefully you can see how this works at home once you get everything working. Now, what we're going to be doing next next tutorial, is adding some sound so that our engine, revs up and down, so we can actually hear what's going on. Just so it's easier to, get a feel for it, and probably improve a bit on the backgrounds and the looks, so it zooms out a bit when we're going faster and things like that. Maybe probably improving a few values as well here and there. So if you enjoyed this tutorial, or if you found it at all helpful, please like and subscribe. This really helps a lot with motivation and making new videos. I hope you enjoyed it, and I'll see you guys next time.